So let's start with an expected value problem. We basically have a set of values and the probability of getting each value, and we want to know in the long term what would be the average value that we would get. So obviously it's going to be weighted heavily to these -2s and -6s here. So all we need to do is copy the data, and then I'm going to show you in Excel. So I'm just pasting the data here. It doesn't really matter where in the spreadsheet. And what we need to do is we need to multiply each value times the probability of getting that. So I'm just going to do an equal sign, select the first cell times the second cell, enter. And then I'm going to grab bottom corner here, drag that so we have the same formula for each column here. And then down here I can see that the sum is -3.8. And that's what I'll be looking at. I could also, if I wanted to, do equals sum and then add these here. Either way, I'm going to get the -3.8 that I'll just put into this. And real briefly, let me speak like what we're doing here. So maybe there's a 0.4 chance that I'm going to lose $1 in a particular game. Maybe 0.4 chance I'll lose $2, 0.1 chance I'll lose $3, 0.1, and so on. If I were to play this game many, many, many times, how much would I lose on average? And that's where that value that I got, -3.8. So I'd lose $3.80 on average if I were to play this game many, many times. Okay, what about variance? I'm going to go ahead and copy that data again, and let's do this in Excel also. So there I'm pasting the data. Let's go ahead and find expected value first, since we just did that. So I'm going to take equals this value times the probability of getting that value, and then I'm going to do that for all of them by dragging it over. And this time I will put the sum formula so we can have this expected value right here. And this I'm going to label as e of x. That's my expected value. And now the next thing I want to do is get my e of x squareds. So what are my x squareds? Well, let me go ahead and calculate x squared here. So what I'll be doing is taking this x value times itself, or you could also raise it to the second power. So these are my x squareds, and now I want to do a similar thing to what I did for expected value, oops, equals sign, except now I'm going to take my x squared times the probability of getting that, and we'll copy that across, and then we'll do the sum of these. Okay, so this is my value e of x squared here. So then the variance itself, I need to take this number I just got and then subtract this number, but I need that number to be squared. So I'm doing, put that in parentheses there, I'm doing the e of x squared, so the expected value of my x squareds, minus my expected value squared. So whatever my expected value is, I'm going to square that and subtract it from my e of x squareds. I know that's a mouthful. And that gives me my variance of 2.24 here. So if you need to find the standard deviation, we're going to do just what we just did, except at the very end. So variance is always, if we take the square root, we get the, this is variance of x. If we take the square root of this, equals square root of this guy, that will give us our standard deviation of x. So we're looking at 1.4966 to 1 decimal point would just be, oh, sorry, I'm not going to put this in. This is different data here, but I wanted to show you the process. So to get the standard deviation, you go through the calculations, get the variance first, and then just take the square root of that. That gives you your standard deviation.